Hello, in this video, I'm going to show you the basics of Sudoku and how to solve any easy level Sudoku. So in today's video, I'm using the May 18th, 2020 New York Times Sudoku puzzle at the easy level. Each row and column in a 3x3 block that's outlined by a darker border needs to be filled out with numbers 1 through 9 without repeating any numbers within the row, column, or square. So let's take a look at this easy puzzle. I like to start off by looking at each of the numbers 1 through 9 at a time to see what we can immediately fill in on the board. So let's start with 1. There's a 1 in this row, a 1 in this row, and there needs to be a 1 in this block, which means that the 1 has to go here, because if it were in this row, it would violate this one here, and if it were in this row, it would violate this one here. So this has to be a 1. And then moving on, let's keep looking at the ones. There's a 1 in this column and a 1 in this column, and there's also a 1 across in this row. But this block still needs a 1, and because of all the other ones that can intersect through that block, it has to be a 1 here. And then we see the 1 here in this row, and the 1 here in this row, and this square still needs a 1, so this needs to be a 1 as well. And then there's a 1 in this column, a 1 in this column, and then a 1 across here. This means that in this square, we need to have a 1 here, otherwise it would violate the other ones that already exist. And now we filled out all the ones for this board. Now let's look at 2's. This 2 in this column extends down into this square, which means that in this square, the 2 is on this side. And if the 2 is on this side, and there's a 2 here, in this square, this has to be a 2. Let's move on to 3's now. There's a 3 here in this column, and a 3 here in this column, and this block is still missing a 3, so it has to go here. And there's a 3 in this column, and a 3 in this column. Extend it upwards into that upper block, and then drag this 3 in this row over to the left, and then we can see that 3 has to be here. So now we're done with filling out the 3's. Moving on to 4's. There's a 4 in this column, 4 in this column. This square is still missing a 4, so this has to be a 4. And then there's a 4 in this column, a 4 in this column. So in this square, 4 has to be here. And then we see a 4 in this row, a 4 in this row. So 4 has to be here in this square. And then we see a 4 in this row, a 4 in this row, a 4 going up this column. So in this square, we can only have a 4 in this cell. And then finally, we have a 4 going this way, a 4 in this row, a 4 in this row. So in this square, this has to be a 4. Now we're done with filling out the 4's. For the 5's, let's look at this 5 here in this row, this 5 in this row, this 5 going down. So in this square, this has to be a 5. Continuing on, there's a 5 in this column, a 5 in this column, which means that this has to be a 5 in that square. There's a 5 in this row, there's a 5 in this row, there's a 5 in this column, which means that 5 has to be here. Now we're done with the 5's. Moving on to 6's, there's a 6 in this row, a 6 in this row, and so 6 must be here inside of the 3x3 block. And there's a 6 this way, a 6 in this column, a 6 across here, a 6 across here, so 6 has to be here in this square. And then we see a 6 in this column, a 6 in this column. This leaves this square as the only cell in this 3x3 block to be a 6. and then there's a 6 here, a 6 here. So then this has to be a 6. Now we're done with the 6s, moving on to 7s. There is a 7 here in this column, a 7 in this column, and so now the 7 has to be here in that 3x3 block. And we see in this block that there has to be a 7 in one of these two cells, which means that 7 has to be here. So we pretend that we carry it on through here, which means that the 7 in this block has to be in one of these two cells, but there's a 7 up there, so this has to be a 7. And finally, let's do the 8s. There's an 8 here in this column, which can be extended up into this 3x3 block, rendering these two cells useless to fill in an 8. So 8 has to be here. And then there's an 8 in this row, an 8 in this row, and so 8 has to be here in this 3x3 block. And then we can drag this 8 down the column into this block, so it knocks out these two cells, so 8 has to go here. And then finally we can see that there's an 8 in this row, and then there's an 8 here, 8 dragging down. This leaves this cell as the only spot that an 8 could belong in. And for the last 8, there's an 8 here, an 8 here, so 8 has to be here. And now we can look at the 9s. There's a 9 this way, which means that in this square, 9 has to be here or here. If it's here or here, and there's a 9 here in this square, this has to be a 9. And then this square is missing a 9, but there's a 9 across here, so this has to be a 9. And then there's a 9 in this column, a 9 in this column, a 9 across. This has to be a 9 in that 3x3. And then this we can drag across to look at this 3x3 block, which means that the 9 goes here. One last technique is to look at the actual rows, columns, or blocks. If they're missing a relatively few number of cells, we can figure it out. So for example, in this row, we're only missing one number, and since 1 through 9s have to repeat once in each row, this has to be a 2. In this 3x3 square, we're missing one number as well. This is a 2. In this 3x3 square, we're missing a number. We're missing 9. And then in this column, we're missing a 2. So if we look at this row here, actually missing a 2 and a 7, but there's a 7 here, so that's a 2. This is a 7. In this square, we're missing one number. We're missing a 9. And then in this row, we're missing one number. We're missing a 7. In this 3x3 block, we are missing a 9. In this row here, we're missing one number. We're missing a 2. In this column here, we're missing one number, which is a 2. In this block here, we're missing a 7. And then finally, in this last column, we are only missing a 2.